Hello dear students, welcome to my channel. Today my topic is theory of equations. Basically we'll talk about polynomials today. So what do you mean by polynomials? Polynomials is an expression of the form a0 x to the power n plus a1 x to the power n minus 1 etc. n minus 1 x plus an, where a0, a1, an are real or complex numbers and n is a non-negative integer and x is a variable called the polynomials in x. Then this expression is called the polynomials in x, provided that a should not be 0, because a0 is the coefficient of the leading term, that is x to the power n, highest power. X is having the highest power, so leading coefficient of the leading term should not be 0. Then the polynomial is said to have degree n. So this is the expression of polynomial, that a0 x to the power n plus a1 x to the power n minus 1 etc. an minus 1x plus an, where the coefficients a1, a0, a1 etc. are real or complex numbers. Okay, so this is the definition, or this is the expression of polynomials. Now look at the few examples for that. Polynomial of degree 0, that is simply a constant, a0 not equal to 0. Obviously it can be any constant, simply a constant. Then we can say the polynomial degree of 0. And a0x plus a1, that is the power, leading coefficient is power is 1. It is called linear polynomial. A quadratic polynomial where the power is 2, highest power is 2, so we say this is a quadratic polynomial. In all the cases we have the a0 not equal to 0. Cubic polynomial, we have x cube as the leading term. And biquadratic polynomial, a0 x to the power 4 plus a1 x cube plus a2 x square. This is your biquadratic polynomial because the highest power of x is 4. Okay, so this is the example. Similarly we can say nth degree polynomial if its power is n, and the coefficient of this highest power should not be 0. Similarly we'll say polynomial of degree 5 x to the power 5 and so on. So this is how we give the examples of polynomials. Now we say what are the equality of two polynomials. Two polynomials of same degree are said to be identical. Look at that. This is the expression of polynomial of degree n, and this is another expression for polynomial of degree n. Here we are using a and here we are using b. They are identical. If a0 is equal to b0, that is equating the coefficients of highest power of n, like powers, x to the power n, x to the power n minus 1. So equating, we will get a1, a0 equal to b0, a1 equal to b1 and an equal to b1. This way we can define the equality of two polynomials. Okay, next definition, a very important definition. What are the zero or roots of a polynomial equation? If alpha be a value of x for which fx becomes 0, that is f alpha equal to 0, then alpha is said to be a root or 0 of that equation fx is equal to 0. Okay, if f alpha equal to 0, suppose a polynomial equation is 0 for some values of x, in that case that value alpha is said to be the root or 0 of that equation. So we'll express some examples for that later on. Let us define another 0 of order r. Alpha is said to be 0 of order r if the polynomial fx, if x minus alpha whole to the power r is a factor of fx. Okay, then we say the alpha is a 0 of order r if x minus alpha whole to the power r is a factor of fx. Otherwise, and x minus alpha whole to the power r plus 1 is not a factor of fx. In that case, alpha is said to be a 0 of order r. Suppose if x minus 1 whole square, then x minus 1 is a factor of order 2 of the polynomial x square minus 2x plus 1 is equal to 0. Okay, this is how we can say 0 of order r. Now we'll express geometrical meaning of roots of an equation. What is the geometrical meaning of roots or zeros of an equation? So we have a linear equation now, y equal to x plus 5. This is a linear equation because you see the power of x is 1. So it's a linear equation. It will represent a straight line. Let us draw the line. This is x axis, this is y axis, and if you draw the line, it will be like this, and this point is minus 5, 0. So this is the root or 0 of that equation, this minus 5, because it's actually the value, that is x equal to minus 5, which is a root, x equal to minus 5, which is a root of equation x plus 5 equal to 0, is actually the value of x, where graph of y equal to fx meets the x-axis or intersects the x-axis. Clear? Where the graph y equal to x plus 5 or x plus 5 is equal to 0 meets the curve at x-axis. Okay, so this is the representation of 0. Now for quadratic equation, here is the example of quadratic equation. If you do the factor of this quadratic equation, it will represent x minus 2 into x plus 1. Okay, x minus 2 into x plus 1. So what does it represent in geometrically? The zeros. So let us draw the diagram here. X-axis, y-axis, and the origin. So if you put 0, it will give you two zeros, x equal to minus 1 and x equal to 2. Okay, so now you draw it represents a parabola actually. This is your 2, suppose. This is your 2. So this is the curve. This represents a curve, parabola. This quadratic polynomial represents a parabola. It intersects the x-axis at 2 points, minus 1 and 2. So minus 1 and 2 are two zeros of this polynomial. That is where the curve cuts the x-axis. That represents the zeros of the polynomial. Where the curve x square minus x minus 2 cuts the x-axis, that is x equal to minus 1 and 2. These are the zeros of this polynomial. Okay, so let us give you the cubic polynomial first. So if you factorize this polynomial, it will give you x minus 1, x minus 2 and x minus 3. So if you draw the coordinate axis once again, so this is your coordinate axis, x-axis and y-axis, and this is origin, and these 1, 2, 3 points are 1, 2 and 3, suppose. So let us draw the cubic polynomial. So this, see, you have 3 factors, 3 zeros. If you equate to 0, that will give you the curve cuts the x-axis at 1, 2, 3. So let us draw the diagram. It will be like this. Yes, this is your cubic polynomial. So your zeros in this case represents the points where the curve fx cuts the x-axis, that is at 1, 2, 3. So 1, 2, 3 are the zeros. So this is the geometric representation of zeros or roots of the polynomial. Okay, clear? So I shall be talking about some quadratic more. So why this nature of the curve is this like this? It's because you see I am talking about in general y equal to ax square plus bx plus c, this quadratic polynomial. So if there are a few cases, case 1, suppose a greater than 0, in that case draw the region. This is the region. So in this case your graph will be like this, and these are the zeros. Suppose the zeros are alpha and beta. So alpha and beta, two distinct factors. So in this case we say this quadratic polynomial has distinct factors, so we have two different zeros where it cuts the x-axis. So in this case, if it is a greater than 0, the curve will be like this. And in case of 2, if a is less than 0, again if you draw the x-axis, in this case you have the curve is like this. That is the, in this case the stable position is downward and stable position is upward. This is the unstable position. This point is unstable point, so this point is upward. So in this case you have two distinct zeros, alpha beta. Look at that. So we say in these two cases you have two distinct factor of these polynomials. So that is why you have two zeros, two distinct zeros, alpha and beta. That is the curve cuts the x-axis at two distinct points. So this is the case of alpha a greater than 0. This is the case of a less than 0. Next, suppose third case. I am talking about third case. Again, a greater than 0. A is positive. That is the leading coefficient. Coefficient of the leading term is greater than 0. Drawing x-axis and look at that. This is the curve. So it's only 1 0, but you have repeated factor. That is the factors are same. That is the factors like this. Your quadratic is like this, x minus alpha whole square. So it touches the x-axis. It touches the x-axis in this case. So a greater than 0 and the factors are equal, or it's a square form because it's a quadratic. So it touches the x-axis. And fourth case, if you draw the fourth case, so it will be like this. In this case also, fourth case is a less than 0. In this, the curve will be downward direction, negative direction, but it will touches the x-axis. That is, the factors are equal, or zeros to same factors and zeros are equal. That is alpha are the zeros. That is why you have this diagram. Now I will draw the fifth case. Fifth case, draw the axis. In this case also a greater than 0. So fifth case, this is the quadratic polynomial. There is no intersection with the x-axis, so this is not factorizable, or there is no zero. Zeros does not exist, or zeros are imaginary or complex in this case we say. So this is the diagram for complex or imaginary roots or imaginary zeros. In this case the polynomial is not factorizable. And you have a sixth case. Let us keep some space for that. A less than zeros. This is the diagram. There is no intersection with the x-axis. In this case also we have the same explanation. So these are the cases where you have two different factors, x minus alpha into x minus beta. That is, this can be written as x minus alpha into x minus beta. So you have two different zeros at the x-axis. It cuts the x-axis at two different zeros or different points, a greater than 0, a less than 0. You have two same factors, a greater than 0, a less than 0. You have this diagram, it touches the x-axis. So alpha is the only zero. You have no intersection, that is no zeros. So imaginary roots or imaginary zeros, a greater than 0, a less than 0. These 6 cases. So I am talking about 6. I hope the 6 cases are clear to you. The 6 diagrams. And this is about co-cubic. Let's move to the more general way. How the diagram is going, some diagram left and rises to the right y. So I will explain that. Suppose if n is odd and that is the highest power of x, and leading coefficient n is positive, then the graph falls to the left and rises to the right. So this is the axis, okay, and this is 0. So n is odd. Odd means it can be cubic, it can be fifth order, it can be seventh order, whatever. So it will be like this: falls to the left, like this, falls to the left and rises to the right. It rises and falls to the left. Okay, this is how you can draw the diagram for n is odd and leading coefficient n is positive. That is why if you have a cubic function will be like this, or fifth order function will be cubic function. You have 3 zeros. Look at that, you have 3 zeros. Next, if n is odd and leading coefficient n is negative, the graph rises to the left and falls to the right. That is opposite nature of this. It will be like this. So let us draw the region now. Graph x-axis and rises to the left, as I mentioned, like this. Again, it's a cubic equation, but this is 0 origin. You have 3 zeros, okay, but n is odd and leading coefficient is negative, so the graph rises to the left. You look at that, rises to the left and falls to the right. So this is how you draw the diagram for n is positive and n is negative. Next case, if n is even order and leading coefficient n is positive, n is even, that is square, quadratic or biquadratic or 6-degree curve. So in this case, graph rises to the left and to the right, both sides. So let us have the axis first. This is the axis, x-axis and y-axis, rises to the left as well as to the right. So let us have the 4th degree curve. Okay, so this is how, like this. So look at that, you have 4 zeros because I am talking about 4th degree curve. So you have 4 zeros. So this is rises to the left and rises to the right. This is the origin, this is x-axis, this is y-axis. So I am talking about a 4th degree polynomial. You have 4 zeros. And last one, if n is even and leading coefficient n is negative, then the graph falls to the left, to the right and to the right. So it will be like this. So it will be in opposite nature of this. So let us draw the curve. This is axis and the graph will be like this. So falls to the left and falls to the right. Look at that, you have 4 zeros again because I am talking about 4th degree polynomial. So this is how you can draw the diagram or get an idea of how to draw the diagram of the graph. This is very, very important knowledge in mathematics. So this is how you are dealing with the graphs. Okay, now I shall be talking about division algorithm. Division algorithm, that is, if a polynomial fx is divided by a polynomial gx and suppose the quotient is qx and after the division the remainder is rx, then the relation is fx is equal to divisor into quotient plus remainder. So this is your division algorithm. This is already you have an idea from the Euclid's division algorithm in integers. So this is, and fx and gx are polynomials of degree n and m respectively. Obviously n greater or equal to m because degree of fx is always greater or equal to degree of the divisor, and qx, degree of qx is n minus m. Obviously the quotient degree is n minus m, and rx is either 0 polynomial or of degree less than m. Okay, so this is the division algorithm. Next we'll state the theorem of remainder theorem. If a polynomial fx is divided by x minus alpha, the remainder is f alpha. That is, if the polynomial fx is divided by x minus alpha, that is fx is divided by x minus alpha, and suppose qx is the quotient and r is the remainder, then from division algorithm or division algorithm for polynomials, we can say this relation fx is equal to x minus alpha into qx plus r. Now see, if you substitute f alpha f alpha x is equal to alpha, then this will be 0 plus r. So it's very clear that r is the f alpha, remainder is f alpha. That is the remainder theorem. You can easily get the value of remainder by substituting alpha if it is divisible by x minus alpha. If it is divisible by x minus beta, then f beta is r, that is remainder is f beta. Okay, this is how the remainder theorem works. Okay, lastly, this is the last topic today, factor theorem. Already we have discussed about factor theorem in graphs. If a polynomial fx be a polynomial, then x minus alpha is a factor of fx if and only if f alpha is 0. If x minus alpha is a factor, f alpha is equal to 0. If f alpha is equal to 0, then x minus alpha is equal to alpha is a factor. That is already we have an idea in the graphs. Suppose in quadratic polynomial, x minus alpha is a factor. That is why alpha is a 0. Look at that. If you go back, look at that calculations, you have an idea. Yes, this is for cubic polynomial. X minus 1 is a factor, so 1 is a 0. X minus 2 is a factor, so 2 is a 0. X minus 3 is a factor, so 3 is a 0. If we conversely 1 is a 0 of this, or 1 is a 0 of this polynomial, then x minus 1 is a factor. 2 is a 0 of this polynomial, x minus 2 is a factor. 3 is a 0 of this polynomial, x minus 3 is a factor. This is how if and only if conditions, that is necessary and sufficient condition, works in factor theorem. This is very important theorem. This is called factor theorem. Just see the proof. X minus alpha is a factor of fx, then we can say fx is equal to x minus alpha into gx for some polynomial gx, because gx is a polynomial. Okay, so f alpha equal, if you substitute f alpha, then f alpha is equal to 0. That proves that if x minus alpha is a factor, f alpha is 0. Now conversely, suppose f alpha is 0 and let r be the remainder, qx be the quotient, like this. R be the remainder and qx is the quotient. Then fx is divided by x minus alpha, then fx is equal to, we say this. Okay, now r is 0 because f alpha is 0. If you substitute alpha, it will be 0, so r is 0. Therefore fx is equal to x minus alpha into qx. Qx is some polynomial, so it represents, it implies that x minus is a factor of fx. Clear? I hope today's class is very clear to you, because you have an idea of the graphs of polynomials. What are the zeros, concept of zeros geometrically, that is very important. And there are 6 cases of quadratic polynomials. How will you draw the quadratic polynomial, cubic polynomials, and lastly special cases if n is positive and the leading coefficient, n is even, n is odd, leading coefficient is positive, negative, such way. So you will follow my videos. The next video I will upload very soon. Thank you.